And the Z of the resistor is 600 ohms with an E to the I 0 because resistors are in phase with their own current.
So resistor phase is always going to be the same as the current phase?
Yes, absolutely. So what do I get from this?
1.86.
1.86. Power supply is 10. Resistor only gets 1.86. Make sense? Yep. Makes sense. Phase of the voltage on the resistor is? And what is the RMS voltage on the resistor?
1.36.
You can either take this over square root of 2, or you could pretend that you put the 2 point whatever in here in the first place. It's just dividing by the square root of 2 well in advance or now. And what do you get?
1.32.
The inductor gets even more than this. How about the capacitor? Even less, because it's only 106 ohms and this resistor is 600. Okie doke. Next calculation is V sub, pick one. Capacitor. Oh, by the way, why am I able to use the total current? Both for the resistor and for the capacitor and for the inductor. Because they're in series and all elements in series have exactly the same current. So, P for RMS. P for RMS. P. I know you guys were waiting to say yes, but I didn't phrase it that way. Because I recognize that you're ready to just make a choice and get on with it. There won't be any questions. Okay. 3.11 milliamps. E to the minus I 79 degrees. The Z of the capacitor is?
Wait, the capacitor, the inductor?
Oh.
What we're doing the inductor?
Oh, we're doing, wait. I started with a clearly written C and my handwriting got worse as it went across. I'm doing the C right now. So the Z of the capacitor was? Times E to the, is it E to the I-90 or E to the I-90? Minus 90. Okay, what do I get?
0.33.
Phase of the voltage on the capacitor is? It can be. It's the impedance of the circuit that's bounded by plus and minus 90. And then capacitors will always be 90%, 90 degrees lower than the impedance of the circuit, and inductors will be 90 degrees the other way. Okay? So, it is possible to have it exactly like this. Okay? Everybody with me? This is that the voltage on the capacitor is way behind. And the reason is the following. First, the inductor won. And it threw the current nearly 90 degrees behind. Now, capacitors need current first. And so on a capacitor, the voltage of the capacitor is even further behind the current. So the resistor dominated this circuit to set 79 degrees delay in the current. And the capacitor will be 90 degrees behind that, for a total of way behind on the voltage of the capacitor. So, interesting, huh? Yeah, and this would be a function of time. This means that the capacitor's voltage is behind the power supply. Okay. Normally, if you only had a capacitor, then it would be 90 degrees. But here, nearly 180. Because you have a capacitor that's being ruled by an inductor. Okay, and dum-da-dum. Last calculation. Now hold on, we need one more first here. The RMS voltage on this capacitor is
23.
So the resistor didn't have much of that 10 volts. The capacitor had even less, and
Inductor has no.
the inductor has the most. And we'll see that in this calculation. So, do we want C e to the I5 format for the resistance of the impedance of the inductor, or do we want A plus IB? C e to the I5 because that was easier. So it was 32. E to the I what? 90. So what do I get for my voltage?
Well, no, that's still RMS. Peak is 10.16.
How much?
10.16.
Oh, not that.
We'll discuss it. It's okay. The phase of the voltage on the inductor is? How much?
11.
The RMS voltage is?
7.18.
How much?
7.18.
Does that answer at first shock you a little bit? Now, the voltage of the inductor plus the voltage of the capacitor plus the voltage of the resistor has to add up to 10 volts. Right? They have to. So how could the inductor be above 10? Yeah, people are saying correct things, but not in the way I'm hoping to hear it. Yeah! How far away is the capacitor from the inductor?
Yeah.
More than 160. How far away is the capacitor's phase from the inductor?
Yeah, 180.
180! At any moment when the inductor has a positive voltage, at that same moment, the capacitor has a negative. Ooh! So that's why the inductor can actually be bigger than the 10. Because the capacitor's voltage is actually in the other direction at that moment in time. Because they're 180 degrees out of phase from each other.
That would be higher than 10 too, right?
Yes, if you went very low in frequency, below this resonance condition, the capacitor can be higher than 10. Neat, huh? I always thought.
What's the resistor?
The resistor will always be bounded by 10. And the reason is, tell me this, which is bigger? Omega L or Z total? In this circuit, which is bigger? Z total is bigger than omega L. The reason is, when calculating Z total, you subtracted the ohms from the capacitor away from the inductor before squaring it. And that's what made the total impedance less than just the one from the inductor. And it could have been the other way around. It could have been the 1 over omega C was the winner, but the omega L coming away from it caused it to have a slightly bigger voltage. Okay. Now, clearly, your circuit is not tuned for F equals 500 megahertz. We've said over and over again that the inductor is taking most of the voltage out of this circuit, which means the frequency is too high. 500 megahertz is too high, giving the omega L an advantage over the 1 over omega C. If we find the resonant frequency, we're going to get a number that's lower than 500 megahertz, and when we do so, that is the resonant frequency that this circuit would send to the resistor. How would we find the resonant frequency of this circuit?
Omega L is 1 over omega C.
Yep. What was L? I forget the number. And what was C? What was C? 3 pi. So what's the frequency? Oh, you're right. Either write the negative 12 or write the... Yeah. Or write the P, but don't write both. So, what do we get?
9 to the 7.
Okay. So I'm going to make that 9 what? Give me more digits.
9.0103.
Okay, so I'm going to call that 90.1 times 10 to the 6. Get it?
Yeah, open call number.
90.1 on your FM dial. That's our radio station, you sea wolves. It's WU.